So Kirchoff's laws is actually one of my favourite things about electricity because I think it explains the way that electricity behaves far better than what you did in level 1 or level 2. But on the other hand, it's a bit weird when you first look at it because, I mean, you look at this and you're like, what on earth is going on? There's 2 power supplies, there's 3 resistors. How do we know what works? You know, and look, these power supplies are pointing in opposite directions. How do we know what this system's going to do? And the answer is, well, we don't yet. We apply Kirchoff's laws to it. There are 2, and they are very simple. There is Kirchoff's current law, and there is Kirchoff's loop law. Now, Kirchoff's current law basically says, well, and I'll just find a little place where I can draw this. Kirchoff's current law, or junction law you might call it, basically says that at any place where wires meet, at any junction, the current going into the junction will equal the current going out. And it should be really simple to understand why. If we have these currents going in, they'll add together to give this current coming out. Obviously, you can't have 3 currents going into a point with only 3 wires. That wouldn't work. Where would all the current go? You know, it can't just like explode into space. So this one is relatively simple. The current flowing into the node or junction must equal the current flowing out. The second one is a little more subtle, but not insurmountable when you're thinking about it. It basically says that if there is a closed path, so any closed path, around any closed path, the sum of the voltages is 0, okay? And I want you to think about it using a nice simple example. So if I go over here again, and here's my battery, and here's my resistor, and another resistor, and it says the sum of the voltages adds to 0. So if I start here, I put in some voltage, I give some EMF or electromotive force to the circuit, and I walk around this circuit in a circle. And when I go past this one, I drop some voltage, I give up some electrical energy, I convert it into heat. And when I go to this one, I give up more. And when I get to here, I'm back to 0. And it's easy to think about, you know, you don't want, when the electrons get back to the battery, when the circuit is complete, you don't want any leftover voltage. It can't go anywhere else. It can't like burst out of the circuit and disappear into the universe. It has to get used up in the circuit. So between these 2 laws, the node law or the current law and the loop law or the voltage law, this explains all DC electrical circuits. From that, you would, in this one here, you would be able to determine, if you knew, you know, a few various things, you'd be able to determine what currents are flowing and in what direction. So we're going to do some worked examples, but often you'll be given say one battery, and you'll be given maybe this current, and you'll be told how big this resistor is. Maybe you're told all 3 of the resistors, and you're told, well, work out how big this other voltage is, and work out how big this resistor is, or work out in what direction the current flows. And this is actually a really powerful tool, even though at first it takes a little while to get your head through, because you have to be able to imagine something you've never seen, the inside of a circuit, what's happening in the inside of the circuit. You're going to need to build your own visualization that if I start here, okay, if I start here with my battery and I walk around my circuit in that direction, what will I see? What will I experience? Okay, and that's not something you've ever done before, but with a little bit of mental training, you can get to the point where this becomes a natural way of thinking about the world. Sometimes you walk with the current flow. Sometimes you walk against the current flow. Sometimes you're going from beginning to end like you're working against the natural potential difference of a power supply, and sometimes you're walking with it. So we're going to solve a lot of problems using Kirchoff's law, and you are going to understand it perfectly and be amazing at it.